Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on naming compounds. So we'll go through and talk about how you name ionic compounds and then molecular compounds, and then we'll do a mixture of both where we don't know which one's ionic and which one's molecular, right? So when we're looking at naming compounds, we have two different types. We have ionic compounds and molecular. Ionic compounds will either start with a metal element, or it'll start with an NH4, which is going to be the ammonium ion. And then the second part of this will always be either a nonmetal or a different polyatomic ion. A molecular compound will only contain metalloids and nonmetals. All right, so in order to be able to identify the type of compound, we need to know what is a metal and what is a nonmetal and a metalloid. So what we can do here is we start with our first metalloid boron, and we just draw a straight line down through here. And then everything that is touching this line or to the right of it is a nonmetal, and everything to the left of this line is a metal. So if it starts with any element that's over in this region, then that means that it's an ionic compound. If it starts with any element that is in this region, that means that it is a molecular compound. So rules for ionic compounds: we check the number of elements in the compound first to see if we have a polyatomic ion. More than two different elements means that at least one polyatomic ion is present there. If it starts with NH4, then the polyatomic ion you're looking at is ammonium, and then everything after that is either going to be an element or another polyatomic. So we first make sure that we know if we're looking only at elements or if there might be a polyatomic ion in play. Once we identify that, then we write out our cation name. If it starts with NH4, it's ammonium. If not, then that first element is going to be by itself, and we just write the name. It's going to be a metal. Then we write the anion name. If it's a polyatomic ion, we name it according to what it says on the formula sheet, and we don't change it in any way. If it's an element, then the element ending changes to IDE. All right, so let's look at some examples here. So first is NaCl. This is only two elements, which means that I don't have a polyatomic ion. So I'm going to just kind of separate the two elements here. Na is sodium, Cl is chlorine, and then because chlorine is an element, I have to change the ending to IDE, making this sodium chloride. Easy enough. We look at the second one. This is three elements, which means that there's a polyatomic ion. If I look at this first element, K is a metal, so that means that it is not a polyatomic ion, and the polyatomic ion is going to be everything that's after the K. There is a 2 behind this K right here as a subscript. For ionic compounds, we don't care about how many of each thing we have. We only care about what it is. So K is potassium, and then if we go to the formula sheet on the back, SO4 is sulfate. So because it's a polyatomic ion, I don't change the ending at all, and I leave it just how it is. So this is going to be potassium sulfate. Let's look at a couple more. Here we have Al2O3. Only two elements means no polyatomic ions, so I'm just going to separate out my two elements. The number of each element that I have, again, doesn't matter because it's an ionic compound. Al is aluminum, O is oxygen, but because oxygen is an element, I have to change it to IDE. And I'm only changing IDE for the second element. So the first element never changes names, right? So aluminum oxide. Okay, let's look at a couple more here. We have CdNO32. Now here we have a situation where we have something in parentheses. If we have something in parentheses, that is an automatic indicator that it is a polyatomic ion. So Cd is going to be by itself, and then we have NO3. The number outside the parentheses doesn't matter because it's not part of the polyatomic ion. Only what's in the parentheses matters, so I can just ignore that. E is cadmium, and NO3, if I look on my formula sheet, NO3 is nitrate. So the name of this compound is going to be cadmium nitrate. All right, easy peasy. Okay, this next example we're looking at here, MgC2O4, three elements, so at least one of them is polyatomic. The only time that the cation is a polyatomic ion is if it's NH4. So if it doesn't start with NH4, then you automatically know that the first element is by itself, and then everything after that goes together. So Mg is magnesium, and if we look at our formula sheet, C2O4 is oxalate. And then because it's a polyatomic ion, I don't change the ending at all. So this is just magnesium oxalate. All right, let's do one more here. AgBr, that's only 2 elements, so I just split it into Ag and Br. Ag is silver, Br is bromine, and then because Br is an element, I change that ending to IDE, and that becomes silver bromide. All right, that's how we do ionics. Let's now take a look at molecular compounds. So for molecular compounds, we use our prefixes. These prefixes are on the periodic table. So if you flip to the formula sheet, in the bottom center, there is a table that says molecular prefixes, and you'll find all of these there. So when we name molecular compounds, we always do the prefix plus the element, and then the prefix plus the element, and the second element changes its ending to IDE, just like we did for ionics. The only exception here, the only thing that's different is if the first element is only 1, then we don't put a mono here. So if you have 1 of the first element, you don't put a mono. If you have 1 of the second element, then you do put a mono. So your compound will never start with mono, but it can have a mono in it. The nice thing about molecular compounds is that there's only ever 2 elements, which means we don't have to deal with polyatomics. If you have a compound with a polyatomic ion in it, it's automatically ionic. All right, so if we look at this, we have 3 AS's. So my prefix for 3 is tri, and then my element here is arsenic, and then I have 7 P's. 7 is hepta, and P is phosphorus. And then I have to change the ending here to IDE, so this becomes triarsenic heptaphosphide. Okay, let's look at this next one. N2O, I have 2 N's, so 2 is di, and N is nitrogen. And then there's no subscript with the O. That means I just have 1. 1 is mono, and O is oxygen. Because it's the second element, I do put the mono here, and you'll notice that there's kind of 2 O's next to each other. In this particular case, we can consolidate those and just make it monox, but sometimes we do and sometimes we don't. Like here, we did triarsenic. You'll learn with practice when you can drop the vowel and when you can't. If you're not sure, then you just always leave the vowels next to each other, and it's totally fine. The last thing we do have to do here, though, is change the ending to IDE. So this is going to be dinitrogen monoxide. And if you want to write it as monooxide, that's totally fine. Right? Let's look at 2 more. All right, so for this next example, I have no subscript next to the C, so I have 1 of them. Because it's the first element, I don't put the mono. Then I have 4 S's, so I have 4 is tetra, and S is sulfur, and then I change that ending to IDE. So this is carbon tetrasulfide. So your compound will never start with mono. The mono can only be with the second element. All right, last up here we have 5 SIs. 5 is penta, Si is silicon, and then 8 Te, 8 is octa, and Te is tellurium, so then I change that ending to IDE, and this is pentasilicon octatelluride. Okay, so now we're going to put it together. So when we don't know if it's ionic or molecular, then we have 2 questions we can ask ourselves. So first we say, does it start with NH4? If the answer to that is yes, it is ionic. If the answer to that is no, then we go to our second question here, does it start with a metal? So if it's on the left-hand side of the periodic table and it starts with a metal, then it is ionic. And if it does not start with a metal, then it is molecular. So any NH4 or metal means ionic. Anything that is starting with a non-metal is going to be molecular. All right, so let's do some examples here. C2P7, if we look at C, C is not NH4, C is not a metal. That means that it is molecular. C is carbon. All right, so if it's molecular, we use our prefixes. I have 2 carbons, so di is 2, C is carbon, and I have 7 P's. So this is hepta phosphorus, and then I change that ending to IDE. Dicarbon heptaphosphide. Next here we have NH4NO2, so we ask our questions, does it start with NH4? It does, so that means it's ionic. So NH4 is all together, and that is the ammonium ion. And if you forget that, it's on the formula sheet. The second part of this is all together as well, NO2, and that is nitrite. So this is going to be ammonium nitrite. All right, let's do some more here. Al2Cr2O7 So here there's a couple different indicators that tell us what this is. So first off, does it start with NH4? It does not. Does it start with a metal? Aluminum is a metal, so yes, and it's ionic. The other way that I know that is that because I have parentheses, I know that there's a polyatomic ion, and a polyatomic ion automatically means that it's ionic. So you can use whatever method makes sense to you to kind of figure out what it is, but it'll get easier as we go through. So for ionic compounds, we don't care about prefixes. We only care about what we have. All right, so the 2 here doesn't matter. The 3 there doesn't matter. All that matters is what these things are. So Al is aluminum, and Cr2O7 is a polyatomic, and if we look at our formula sheet, we see that it says dichromate. So this is aluminum dichromate. So again, because it's ionic, I don't care about the prefixes or the number that I have. I only use the name of the cation and the name of the anion. Next up, Se6Te. Se is not NH4. Se is selenium. It is a nonmetal, which means that this is molecular. So that means that I'm going to use my prefixes here. 6Se means that it's going to be hexa, and Se is selenium. And then I have 1 Te. So because the 1 is on the second element, I do put a mono here. And then my element is tellurium. So I change that ending to IDE. And this is hexaselenium monotelluride. All right. Next we have Zn3BO3 So this is again a situation where I have something in parentheses, which means that that's a polyatomic ion, which means it's going to be ionic. But we can also go through our checklist and say Zn is not NH4, but Zn is a metal, so that means that it's going to be ionic as well. So I only care about the Zn and the polyatomic, which is BO3. Zn is zinc. BO3, if I look at my formula sheet, is borate. So this is going to be zinc borate. Next up, NF5. N is N, but it's not NH4. In order for it to be NH4, there has to be an N and 4 H's, but this doesn't have that, so we just look at the N by itself here. N is not a metal, it is a nonmetal, so this is going to be molecular. I have 1 N and 5 F's. So molecular means prefixes, but since I only have one of the first element, I do not use a prefix. And then 5 is penta, and F is fluorine. N is nitrogen. I don't think I said that. All right, and then we change the ending to IDE, so this is just nitrogen pentafluoride. All right, awesome sauce. Let's do some more. Na3ASO4. So Na is not NH4, but Na is sodium, which is a metal, so this is ionic. I can also see here that there's 3 elements, so anytime I have more than 2 elements, it has to be ionic because one of them is polyatomic. All right, so I just separate these. I have Na and I have ASO4. So Na is sodium. Again, I don't care about this 3 here because it's ionic. And then ASO4, if I look at my formula sheet, is arsenate. So this is going to be sodium arsenate. All right, next one here, B4Cl9. B is not NH4. B is boron. It is a metalloid, which means it is molecular. B is actually on our dividing line. So I have 4 B's and 9 Cl's. 4 is tetra, so this is tetraboron. 9 is nana, so this is nana-chlorine, which then changes to chloride. Tetraboron, nana-chloride. All right, let's look at some more here. I have GaOH3. Ga is not NH4. Ga is gallium, which is a metal, so this is ionic. So Ga and then OH. Again, I also know it's ionic because I have this in parentheses. Again, I don't care about that 3 because it's ionic. Ga is gallium and OH is hydroxide. You can find that on our formula sheet. So this is gallium hydroxide. All right, last one here, PO8I3. PO is not NH4. PO is polonium, which is a nonmetal. So this is going to be molecular. So I have 8 POs and 3 I's. 8 is octa, PO is polonium, and 3 is tri, and I is iodine. All right, so this is an instance where I have 2 I's next to each other. I kind of have to leave those there because it's triiodine. We don't want to do triodine. I guess you could, but we just leave it this way. All right, and then we change that ending to IDE. So this is octapolonium triiodide. Okay, so this is how we name ionic and molecular compounds. This has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.